Populations, Samples, and Hypotheses, Part 2. All right, we're up to example 3. It says finding a sample proportion. Use technology to simulate rolling a die 50 times. What proportion of the 50 rolls results in an odd number? All right, so if you go to your textbook, you can see that there is different interactive tools. And if you go to the math tools, you can find the one that says probability tools. So if you click on probability tools, you'll see in the bottom, there's a coin, a die, you've got a spinner, you've got a deck of cards, and even a paper bag if you wanted to put so many different items in the bag and draw so many out at a time. But anyways, these are different probability tools. So you can have numbers, dots if you want colors instead, but let's just go with the number die. So you can click on this and you can simulate rolling a die. Okay, this is just a random simulator, and you would do this for 50 times and just write down the results. So I'm going to pretend like we've already done this 50 times and kept the results, and we're going to look at what happened. All right, so we rolled the die randomly 50 times using technology. So we just used the random die on the website to do that. And here's the results. I've just jotted those down. So it says, what proportion of the 50 rolls results in an odd number? All right, so we know which ones are odd. So to represent an odd number, you're going to have 1, 3, and 5. So what we have to do is figure out what proportion out of 50, which means something out of 50, and that's going to be our proportion. So we start with 6, and then we add that to 9. So 6 and 9 is 15, and then 23. So that's going to be 23 out of 50. And that can be written as, let's see what that is as a decimal. We know 25 out of 50 is 1/2. That would be the theoretical probability. We know the more times we roll, the closer it gets to the theoretical probability. That's the law of large numbers we talked about back in chapter 6. So let's see what we get here. Okay, so this is going to be about 46%. Or this actually equals 46%. But again, if we roll the die again, we'd get something slightly different. We roll it again, we may get something slightly different. We roll it again, we may get the same thing or something slightly different. But the point is, the more times you roll the die, the closer it's going to be to that 50%. And the reason it would be 50% is because 1, 3, and 5, there's 3 out of 6. Half of the numbers are odd, and we're looking for the proportion of 50 rolls resulting in an odd number. Example 4, analyzing a hypothesis. You roll a 6-sided die 5 times and do not get an even number. The probability of this happening is 1/2 to the 5th power equals about 3.125%. So you suspect the die favors odd numbers. The die marker claims the die does not favor odd numbers or even numbers. What should you conclude when you roll the actual die 50 times and get 26 odd numbers, and then you do it again and you get 35 odd numbers? All right, so let's look at this probability thing. So it says you roll a 6-sided die 5 times and you do not get an even number. That means 5 times in a row, you got an odd number. So remember, on a 6-sided die, 3 out of 6 numbers are even, 1, 3, and 5. And then 3, 2, 4, 6, 3 of the 6 numbers are even. So 1/2 to the 5th power represents the 50% chance each time you roll times the 5, or raised to the 5 power represents the 5 times you rolled. So that's going to tell you that it's only a 3% chance that you get an odd number every time. So do not get an even number means getting an odd number. All right, so what should you conclude if you roll the die 50 times? Well, the larger the number gets, the larger, the law of large numbers, the bigger the number of rolls, then the closer it should get to that true 50%. So if you roll it 50 times and you get 26 out of 50, 25 out of 50 is 50%. 26 out of 50 has to be slightly over 50%. So that should make sense. You could actually get that number, and that would be about 52%. So that does make sense. So 0.52 or about 52%. So if I got 26 out of 50 rolls, I would believe the guy that said that it does not favor odds. This is a good die. All right. Now, however, if you roll it 50 times and B part says you get 35 odds, well, 35 out of 50, that's a little bit different. All right, so if you get 35 out of 50, what percent is that? All right, that's 0.7, so that's about 70%. That's going to make you question whether that die is actually good die or if it does favor even or odd numbers, whatever it is. So what could you do to change this hypothesis? Like, what could you do if you got 35 out of 50? This is highly unlikely. If you roll it 50 times, it's highly unlikely. If it's a good true die that's equally likely to roll and land on any of the 6 sides, it's highly unlikely that you get 35 out of 50 that are not even. So what you would need to do is maybe do a simulation of more than 50 times. Let's say 200 times. So maybe you roll it 200 times, and then if you roll it 200 times, hopefully you're getting closer to that 100 out of 200, that 50% chance would be. But it would be harder to conclude that this is a good die if, in fact, you got closer to 70% when you rolled it 50 times.